Okay, we continue with Time Zone 1 Paper 2. This is SL, AA, AASL. So, yeah. Again, the paper should be quite difficult to find. So, in case you want to try it before watching it, take a screenshot. Question 1. Question 2. Question 3. Question 4. 5. 6. 7. 8. Oh, have I seen this question somewhere before? Huh. I don't know if it's similar to a past paper or... Oh, this is also question 8, continued. I don't know if I've seen the same question or actually... I don't mean I actually seen the same question from this paper or question 9 continued, or it's just a similar past paper question. I can see the whole paper is like not crazy. There's no crazy new stuff. Yeah. So question 1, integrate. So I hope you don't need help on this. You add 1 to the power, and you divide by the power. If you integrate a single number, you attach an x to it, and don't forget the plus c. For b, they tell you the derivative of some function is 6x plus 7, so that would mean the original function is obtained by integrating the derivative, because integration is the opposite of differentiation. So we did that already. Actually, we just simplify this. So like this. But if it's an actual function, then you have to find the value of c. So it's telling you that if x is 1.2, the function would equal to 7.34. The rest should be a simple GDC work. Right. I mean, I totally feel like skipping actually pressing the calculator, but I guess that would make it a full solution. So C is whatever it is. You should always remember to actually answer the question. So write down what fx is actually is, because they do want fx. Scatter plot. So should be obvious. Use your GDC of choice to find the regression line. You probably would not have the GDC that I have right now, so do it in your way. It's probably spreadsheet or statistics, that kind of thing, and then you go stat calculation, linear regression, ax plus b. Alright, that kind of thing. So get to know your calculator. It is very important, as these are easy mark, and there is basically no other way. You can't do it. I mean, there is a way. There is a long formula that you can technically do by hand, but it's very time consuming, even if you magically knows that formula. Okay. So again, I'm sure your way of doing is different from mine. So here is my regression there. So value of a obviously is technically the gradient of the regression line. B, that. Use the model to predict y when x is 18. That's easy. You just simply substitute 18 into the regression line, so into here, plus b. Do I want to do that? Let's do that later, because I need the value of x bar and y bar. That's the mean of x and mean of y. It is possible that if you have done two variable stat instead of linear regression, you will have the mean already, which I do. If it happens, your calculator is different, so it doesn't automatically calculate for you already, or you didn't use two variable stat, then you can go back to one variable stat and then find the mean of x and find the mean of y separately. Right? Anyhow, is the job of the GDC. So x bar, which is the mean of x, is 15, y bar is 11. Alright, then I can go back to calculate the prediction of part B, 0.433 times 18 plus 4.5. So my prediction is 12.249. You should always at least write 3 sig fig. IB do not penalize for writing more. So if in doubt, just copy everything shown in the calculator. You pretty much would not lose anything unless the question specify. Like in that particular question, if it says correct to 1 dp, then you have to do it. You cannot do more. But if it doesn't say, you can always just write as much as you can. Draw the line of best fit. Alright, the key would be the line of best fit always pass through the mean point. Alright, which is the point formed using the mean 15, 11. What is 15, 11? 15, 11 is roughly here. Usually we draw a circle to say that it's not an actual data, but only the mean. Another point we will use is B, 4.5, which is the y-intercept of the line. So the y-intercept is 4.5, so like here. And then you were supposed to use a ruler. I'm lazy. And you joint the y-intercept and the mean. That would be the best way of drawing the line of best fit. Okay, let's keep going. Here we have a normal distribution. The rest doesn't even matter. The mean is 1,000, so the symbol for mean is mu. Standard deviation 3.5. The symbol is sigma. Alternate is sugar. Is rejected if the mass is less than 995. What is the probability that the thing is rejected? Alright, so if you're fancy, you can write x follow normal distribution with mean and variance. That's the conventional symbol, but you can totally skip that. You don't have to. Alright, so the probability that it is rejected is when the mass is less than 995. Obviously, this is the work of GDC, usually called NCDF, normal CD or normal CDF. Your calculator again is probably not. It doesn't look anything like the one I have right now. Actually, I don't even know how to do it with my calculator. Is it inference? Yeah. Because I don't usually use this one. I usually use the TI one. They're pretty bad. They're actually pretty bad. I do not recommend that to anyone. 995. In case you wonder for continuous distribution with or without. Let's write more than 3 sig fig. With or without equal is the same. B, estimate the number of bags that would be rejected if you have 100 bags. Well, the probability that one bag is rejected is this. So the number of bags that you expect, alright, to be rejected would simply be 100 times that. So you would expect like 7.66 of them. Alright, expectation by definition do not have to be actually possible in real life, so a decimal point is accepted. given that the bag is not rejected, find the probability that the mass is greater than 1005. So this is a given question. It's called a conditional probability. Alright, you need to go to the formula booklet, go to the probability section and find the conditional probability formula. Alright, it looks something like A given B equals to A intersect B over B. Alright, the line is set as given. A is the thing that they're looking for, B is the thing that is given. So A, what do they want? They want that the mass is greater than 1005. The given thing is that the bag is not rejected. To be rejected, it would be less than 995. So if it's not rejected, then it's bigger than 995. Then according to the formula, we have A intersect B over the given thing. Remember, the B is the given thing. Alright. Now the probability that it was less than 995 was this. So the probability that x is bigger than 995 is simply 1 minus that. Again, for continuous distribution, such as normal, the equal doesn't matter, because the probability that x equal to exactly 995 is 0. But for binomial, which is discrete, it would matter, right? It would not be 0, the probability of x equal to a certain number. Now here, the intersection sign, so here, it means and. Alright, so you need to think what is the meaning of x being bigger than 1005 and bigger than 995. Alright, so if you think about it, it means x is bigger than 1005. Right, because if x is bigger than 1005, then it is already bigger than 995. Right, so you just need to be bigger than 105, where that probability is obviously found with a GDC. Usually you would do NCD, and then for the lower bound you put 105, and upper bound you put like a huge number like 99999 or 9 times 9 to the power of 99. For my calculator, I cannot choose that, so I will put 105 and then 1 minus that instead. Okay. But in case you want to check, when you do NCDF with 105 as your lower bound, you should get, okay, if you do that directly, you should get 0.076564. Oh, of course. 105 and 995 are both 5 away from the mean. They're symmetric. Of course the probability is the same. Well, okay. I mean, I didn't notice that, but still fine. So the final answer would be that thing over that thing, 0.0829 for 3 significant figures. Ferris wheel trigonometric graph question. This time they want a cosine graph. Alright, so this type of question was really popular in the old syllabus SL. Seems like the popularity hasn't changed. So the key is, no, we can take the time to read the information. But the key, it would be the wheel start from the lowest point, so it's like 10 meter, and it will go up to the top, then go back down. Alright, so the height of the wheel follow a cosine graph. this cosine graph has a period of 20 minutes because it takes 20 minutes to complete one cycle. So this is 20. All right. It should be fairly obvious what is the maximum height because it have a diameter of 110 plus the 10 meter on ground, so 120. Okay, so first you have to see this from all the information. The question is, what would be the formula for the cosine graph? In particular, what's the value of A, B, and C? All right, let's do A first. A controls something called amplitude. Amplitude, if you know, is you go to the middle of the graph called the principal axis, and then you measure from the middle to the top how far that is. Then you can ask, how do you find the middle? The middle is like the middle of 120 and 10. So it's 120 plus 10 divided by 2. That's how you find middle of two numbers. So you get 65. So you go from 65 to 120. So the amplitude is 55. Alright, that's also obviously half of the diameter, right? The radius. So the amplitude is 55. That means A is supposed to be 55. Except a normal cosine graph go from the top to the bottom instead of starting from the bottom. What that means is they have reflected the graph along the x-axis. What that means is A should be negative. Alright, because in order to reflect a function of the x-axis, you have to add a negative in front. So that's our A. C is actually the easiest. Let's do C first. C is actually the middle line, the principal axis thing. So we had it 65. So C is 65. Then the hardest thing, kind of hardest thing is the B. B control the period. So you should know that the original cosine graph, if it's the original cosine graph, it has a period of 2 pi. So we take 2 pi radian to complete one cycle. But now you only need 20. The unit doesn't matter. We don't care about unit. Only need 20 to complete a cycle. Well, only. Well, I don't really mean only. 20 is technically bigger than 2 pi. So you can imagine this is actually horizontally stretched. But usually we don't think about that because if you remember, if you think about it, if B is like 3, then this is really a horizontal compress by 3 times. Then the period of the graph would becomes 2 pi over 3 because originally it takes you 2 pi to complete the cycle. But if you horizontally compress it 3 times, then now it will only take you 2 pi over 3. So we have the same idea. So the idea is 2 pi over B should give you the period, which is 20. Okay, this works for both if the graph is stretched or compressed. Then we multiply B to the side, and we divide the 20. Cancel out. So B is pi over 10. Okay, again, very popular type of question. This would be a very basic kind, actually. So 5 is kinematics. I think this type of question have come up several times already. They give you the V. They even give you the graph, which you can graph it with your GDC yourself anyway. Find the smallest value of t for the particle to be at rest. At rest means the velocity is 0. So when v is 0, that's here. Right? It could also be here, but they want the smallest one, so it's this one. Obviously, all you do is you plot on the GDC. So But be careful to turn your GDC to radian mode. Oh, they read my expression wrong. Maybe this. See if this solves the problem. Yep, pretty much. We just want the x-intercept, so obviously that's something the calculator do. It is 6.74. Total distance traveled, so that would be like the total area. So if your GDC can input an integral, which it probably can, you can just do integral from 0 to 10 of Vt. Alright, but to make sure they would add all the area as a positive number instead of whenever the area is under the x-axis, it will make it negative. You add an absolute value sign around the function, so you have to find that symbol in your calculator. So let's do that. So here we have what, 0 to 10 absolute. So I think I saw that here for mine. So you have to figure out yours. X times sine x minus 3. Okay, something like that. That should be it. That should already be the answer. 37.1. C, find the acceleration when t is 7. Obviously, the acceleration is the derivative of v. So you pretty much want to find the gradient of this curve when t is 7. Again, your calculator should be able to do that. There are two ways. One way is you like type in the derivative, right? So x times sine x minus 7 minus 3, right? And then you tell the calculator I want x, I want the derivative when x is 7. So there it says it's 5.93. So that's the answer. The other way would be you go back to the graph, and then here you should be able to. Most calculators have the function of finding the value of a derivative. Yours may not be this obvious. It probably look like d dx or something. So let's do that. And then you make x to be 7. Then it also says the derivative is 5.93. Okay. So your calculator might work a little bit different, but the similar function should exist. It should be able to find the gradient on a particular point of a graph. So you can play around with your calculator to find that. Next is binomial expansion. I believe this is the first time in IB that they make the power n plus 1 instead of n. Which, if you think about it, it actually makes no difference. Right? Had the question been just to the power of n, the answer would simply be 1 bigger than the answer they have now. Alright, because if n is 4, then n plus 1 is 4, then n is 3. Right? Other than that, the math is the same. So, is there a pity way to make the question harder? So if you see that, you can totally just replace it. So you like let n be n plus 1, and then you just do this instead. Just go on to find the coefficient of x to the power 4. Then you find m, and whatever m is, you just take 1 away, then you find n. Alright, but I guess most of you didn't do that. So I guess I'll stick with n plus 1 to do this question. So the key of doing expansion is using the so-called general term. So for a plus b to the power of n, the general term would be Ncr a to the power of n minus r b to the power of r. Alright, this thing is kind of given in the formula booklet, right? In where they give you the binomial expansion, this is like the middle term in that long formula that they have in the middle. There should be this exact thing. This is the general term. So you pretty much use this on on the question. So the n is the power. So the power they have is n plus 1. Cr a to the power of, now n is n plus 1 minus r. Well, actually a is the first thing in the binomial expansion. Then b is x squared. So x squared to the power of r. Okay, three things multiplied together. And then the key is you kind of guess what should r be, so that you can have x to the power of 4. Right, this time it should be obvious. You have x to the power of 2 to the power of r. So if you want an x to the power of 4, you make r to be 2. So say you take r to be 2. So 1, 2, 3. So it's n plus 1 minus 2. R is 2, right? 2. Okay. Now we just care about the coefficient, so the x doesn't really matter. So the coefficient is 20412. Alright, coefficient means you don't count the x. So now we want to solve this for n. A solver would probably do it. Except we will try. Most calculator cannot handle an unknown inside the Ncr function. Alright, so most usually you have to simplify that a bit using the Ncr formula. So if you go to the formula booklet, they'll tell you Ncr is n factorial over r factorial over n minus r factorial. So in case you don't know, for example, 4 factorial is 4 times 3 times 2 times 1. Alright, that's the meaning of factorial. So using that, we have n plus 1 c2. So this is the n. So n plus 1 factorial over r is 2. So 2 factorial. And then n minus r, so n plus 1 minus 2 factorial. Okay, times 3 to the power of n minus 1. Okay, then we will need to do the factorial a little bit. So if it's 4 factorial, you start from 4, and then you keep taking 1 away, and you multiply. So for nc1 factorial, you start with n plus 1. Sorry, n plus 1 factorial. For n plus 1 factorial, you start by n plus 1, and then times n plus 1, take 1 away, so that's n. And then you have n, take 1 away, so n minus 1, all the way to 1. Okay? You keep going until you get to 1. Alright? 2 factorial, 2 times 1. And then this is n plus 1 minus 2, so n minus 1. Alright, so we have n minus 1 factorial. So again, we start from the thing you do the factorial with, so it's n minus 1 times, you take 1 away, so n minus 1 minus 1, so n minus 2, so on and so forth until 1. Okay. So this is where the simplifying happens. We have n minus 1 times the next one, which you take 1 away, so n minus 2. Keep on going until you get to 1. Well, we get the same in the bottom, so they cancel out. Okay, so it becomes n plus 1 times n over 2 times 1 is 2 times 3 to the power of n minus 1 equal to whatever that number is. This is where you can use a solver or using a graphing method to solve this. I personally like to use a graphing method because with a graph, you can see if there is more than one answer. However, for a graph, you might have to adjust the windows by yourself. So if you have no idea roughly what the answer would be in, like the range, would it be between 1,000 or between 10 or between 0 to 1, it could be slightly difficult to set the windows correct. On the other hand, the downside of NSolve would be they always only give you one answer. So if the question have two answers, you probably lost the second one, unless you know specifically that there is two and you actually look for it with NSolve. I forgot the times. The 3 to the power of x minus 1. So that should work. So I plot it. No. Plot it. Now, so you can see I need the red line to go up to the blue line to see it. So I probably need a lot more x. So this is what I mentioned about setting the windows. For me, that's not what I want. So I know x should probably be way bigger. So maybe 0 to 60. 60 should be enough. Like power of 60 is a lot. Right. So yeah, you can see the answer is actually way less than 10. No, not way less. A bit less than 10. But that's good enough. We go find the intersection. 7. So n is 7. And you can probably guess that there's only one answer because the red graph seems to be going up. So you have no chance, probably have no chance of coming back down to meet the horizontal line again. So that's question 6. We'll do section B in the next video.